Hi everyone, today we're going to go over 4-7, which is transformation of quadratic functions or graphs. We're basically going to be talking about how the graph moves compared to its parent function. So one of the things that's really useful is actually vertex form. Vertex form I also like to call transformational form because it will tell you the transformations that occurred. So we can take a look at writing vertex form. So we notice it's not a perfect square. So this is also where we're going to tie in some of the things we've used in the past, which is also known as completing the square, is one option we do have. And it's all about balance. So we're going to take half of our b value, square it, and add it. Notice we have set up parentheses though, so that we're looking at these two here. We cut off our c value. So then we're going to head and write our perfect square of x minus 1 squared plus 3. And so that would be our perfect, our vertex form. Another option you do have is that you can go ahead and use the formula for axis of symmetry to find your x value of your vertex and then plug that value in and get your y value of your vertex. Because the reason this is vertex form is because we refer to this as y equals a times x minus h squared plus k, where h comma k is my vertex. So the reason this is so helpful is that because if I want to just know my vertex by looking at it, I can tell you as well as telling you the transformations. So we're going to do the same thing. We're going to write y equals negative 3x squared minus 18x plus 10. And we're going to write this in vertex form to analyze the function. So we're going to head and start by dividing by ax squared and bx. And we're lucky enough that b is a multiple of our a value. So we're going to complete the square by adding 9 inside the parentheses, and we're going to subtract negative 3 times 9 on the outside the parentheses. So we're going to write this as our perfect square, negative 3 times x plus 3 squared plus 37. So that is our equation for vertex form. Oh, I thought we were supposed to analyze the graph. They analyze the function. So looks like they missed a part of it, but we're going to head and talk about. I can tell you right now that this negative 3 tells me it is a vertical reflection over the x-axis, which tells me that it opens upside down. This plus 3 tells me it has moved left 3 units from the parent function, and that the plus 37 means it has moved up 37 units, which is really good information to know, especially if you're trying to graph something. I know kind of where I want to start. So go ahead and write y equals x squared plus 6x plus 5 in vertex form. Let's go ahead and take a look here. So we're going to go ahead and isolate x squared plus 6x plus 5 on the outside. I'm going to take half of my 6 value and square it. So I'm going to add 9 on the inside and subtract 9. By doing that, we're going to get x plus 3 on the inside. And then we're going to get minus 4 on the outside. So that means our answer is D. Let's go ahead and take a look at our next two try. Y equals negative 3x squared minus 18x plus 4. So I'm going to give you a moment to go ahead and do that. All right, let's go ahead and take a look at this. We're going to head and factor out a negative 3 from the first two. So we're going to get x squared plus 6x plus 4 on the outside. I'm then going to take half of 6, square it, and add it on the inside, which gets me 9. And I'm going to subtract my a value times what I just added. So we're going to get -3, and this simplifies to x plus 3 squared. And this is -27 plus 4 is -23. So our answer is minus -3. Oops. So that actually does change our answer. So we're going to get 4 plus 27, which is 31. And so that does make our answer B. Taking a look at our next example, we have which equation would match the function of the graph shown. So one of the things we really do want to look for is our vertex here. And that's going to help us out a lot. But you're going to read the graph and you need to find the equation. We do know that the vertex is at 2, -3. So as we can see, 2, -3. So that means our h value is 2 and our k value is -3. So we can go ahead and substitute these values to solve for our a. So 0 and -1, we simplify and find that 2 goes for a. So a is 1/2. So our equation is 1/2 x minus 2 squared minus 3. In this case, the answer choice was B. So let's go ahead and try this one, which is the equation of the function shown in the graph. All right, let's take a look. So we can see that our vertex is at -1, 2. So I do know that it's going to be x plus 1 plus 2. And with that, we can actually help ourselves out in that it's going to open that we have the plus 1. I can cross out B, and I can cross out D. It also opens downward, so that does tell me I have a negative A value. And by process of elimination, I know the answer is A. We can also go ahead and use a value that we do know is true, which would be, I would try this one here. One of those two, so that would be when x is 0, y is -1. So I could do -1 equals 0 plus 1 squared plus 2. And we have our a value in the front. So we get -1 equals a plus 2. I subtract 2 and get -3 equals a. So here we have transformations of quadratic functions and what sort of happens when we have a, h, and k. So when we're looking at our parent function, which is x squared, which means h is 0, k is 0, and a is 1. So when we have a negative h value, it goes to the right, and when we have a positive h value, it goes to the left. So it's opposite of what you think. K, when it's plus k, we go up, minus k, we go down. When a is negative, our graph is flipped upside down. And then we have our dilations, which when the absolute value of a is greater than 1, it is a thinner graph or a stretched graph. And when the absolute value of a is less than 1, it is a compressed graph, or we also call it it's wider. Just to make a note that when you just shift your value up or down, it doesn't make the graph any larger or smaller. It just changes how much of the graph you can see. So k has nothing to do with the size of the graph. All right, so we're going to head and graph y equals -2x squared plus 4x plus 1. You're going to write the equation in vertex form. And so we can go ahead and do that, and we get y equals -2 times x minus 1 squared plus 3. So you can plot your points. To graph this one, you'd plot your vertex, and because the graph, we know it's -2, one of the things I like to do is it's go over 1, down 2 would be my a value. Go over 1, down 4, you just multiply by 2, -2. So there we go. So go ahead and graph 3x squared plus 12x plus 8. All right, let's take a look. Here we have a couple things we can help us out since this is a multiple choice test. A is positive, so that does tell me automatically that it does open upward. And by knowing that, we can cross out A automatically. So we're going to go ahead and rewrite this in vertex form. So we're going to go ahead and factor out a 3. We get plus 4x. I'm going to take half of 4, square it, which is 2, and 2 squared is 4. So we're going to add 4 on the inside. And then we have plus 8. And we're going to subtract 3 times our inside value, which was 4. So we get 3 times x plus 2 squared minus 4. So I know my vertex is at -2, 4. A comma -4 here because it is a -4. And with that, I know it is B. That is the end of our notes, and I will see you next time for 4-8. Bye.